Imagine a computer so powerful it could process data millions of times faster than any device you've ever encountered. Welcome to the world of quantum computing, where the rules of the game are dictated by the strange and fascinating laws of quantum physics. Now, what exactly is this quantum computing? In essence, it's a type of computing that uses quantum bits, or qubits, instead of the binary bits used in classical computing. While classical bits can be either a 0 or a 1, qubits can be both 0 and 1 at the same time, thanks to a quantum phenomenon known as superposition. Adding to the peculiarity of quantum mechanics, there's another principle called entanglement. When qubits become entangled, the state of one qubit becomes directly related to the state of another, no matter how far apart they are. This intricate dance between superposition and entanglement allows quantum computers to process massive amounts of data simultaneously, potentially solving complex problems that are currently beyond our reach. But it's not all smooth sailing. Quantum computing comes with its fair share of challenges. Error correction, decoherence, and scalability are just a few of the hurdles scientists are trying to overcome. But don't be daunted. These obstacles are the stepping stones to progress, paving the way for advancements in the field. So, what's the big deal about quantum computing? Why does it matter? Picture this: breaking complex cryptographic codes, optimizing logistics on a global scale, revolutionizing machine learning. These are just a few of the potential applications of quantum computing. The possibilities are as vast as they are exciting. Now let's journey back in time for a brief history lesson. Quantum computing is not a new concept. In fact, it dates back to the early 20th century, when great minds like Max Planck and Albert Einstein were making groundbreaking discoveries in quantum mechanics. Fast forward to the present day, and we're witnessing the dawn of a new era in computing, with tech giants like IBM and Google leading the charge in quantum technology. In the realm of quantum computing, famous algorithms like Shor's and Grover's have taken center stage. These algorithms, with their potential to outperform any classical algorithm, serve as a testament to the immense power of quantum computing. As we delve deeper into the world of quantum computing, we come across various types of quantum hardware, including quantum processors and quantum gates. Quantum hardware is at the heart of any quantum computer, and it's this intricate machinery that allows us to manipulate qubits and perform quantum computations. To wrap things up, let's peek into the future. The road ahead for quantum computing is filled with promise and challenges alike. With continued research and innovation, we could witness a quantum revolution that will redefine the boundaries of computation. So there you have it, a whirlwind tour of the fascinating world of quantum computing. Remember, this is just the tip of the iceberg. There's so much more to learn, to discover, and to explore. So stay curious and keep exploring the quantum realm.